Hello friends, I hope all is well. Today I will show you how to calculate the volume of any liquid inside a plastic bottle. As you can see on my screen, I have a 3D model of a plastic bottle. Next I will show you how quickly find the volume of any liquid inside the bottle. I hope you will enjoy this video. If you like it, please subscribe to my YouTube channel. Here I have a thin walled part designed to hold some kind of fluid like soda. With a model like this, I can easily find the volume of the plastic material that makes up this body by going to the Velvet tab and selecting Mass Properties. This is a great for gaining some understanding about the material used to manufacture the bottle, but it's also important as a designer to know the volume of material that is in can hold as well. To do this, I will use an approach of creating a feature that fills the cavity inside the bottle in order to represent the liquid, which I can then use to find its volume using the Mass Properties command. To create the geometry that fills the inside of this bottle, I will be using the intersect feature. This intersect feature allows me to specify a region or regions of enclosed geometry that I would like to add or remove from the bottle. In this case, once I am finished using the intersect feature, I will be left with only the volume that fills the bottle. The bottle itself will be consumed in the intersect feature. That said, before I create the intersect feature, I would like to quickly create a new configuration of the part. That's why I will have one configuration with the bottle left intact and a separate configuration representing just the liquid from the intersect feature will at the moment. Also, this configuration will be available in case I need to make design changes to the geometry of the actual bottle later. To create the new configuration, I'll click the configuration manager icon, right click the part name and select add configuration. I will enter the new configuration name and click OK. And the configuration I just created is now the active configuration. At this point, I will switch back to the feature manager tree. Before I use the intersect feature, I would like to determine the fill level of the liquid, since in reality it would not be filled all the way to the very top. To do this, I will create a reference plane by going to the reference geometry icon on the feature toolbar and selecting plane. This new plane will be parallel to the top plane, and since I know this bottle happens to be 220 millimeters tall, I will use an offset distance of 190 millimeters for what will be the fill level. I will click OK and the reference plane is added. This plane intersects the geometry at our fill level and will serve to enclose a volume inside the cavity of the bottle that we will be able to isolate using the intersect feature. Let's take a look. I will launch the intersect feature, which can be found on the feature toolbar or from the insert feature drop down menu. In the property manager, I will select the bottle and the reference plane. When I click the intersect button, you can see this leaves us with 3 enclosed regions based on my selection. It leaves the upper half of the bottle, the lower half of the bottle, and there is also an enclosed volume inside the bottle. As a side note, had this bottle had there would have actually been a fourth enclosed volume representing the air in the bottle above the line. In the property manager, I just have to tell Solidworks which of these regions I would like to remove. In other words, exclude from the solutions. I'll select both regions of the bottle, leaving, and there you can see the result. A single solid body representing the volume of liquid specified up to the fill line. At this point, I can check the mass properties. And here I can see this has a volume of approximately 590 cubic centimeters. To finish up, I will switch back to the default configuration. And you will see that the plane and the intersect feature are both suppressed.